Hello students and welcome to my channel Maths Hub. So in this video I'll tell you about the concept of differentiability. So before watching this video, please watch the other two videos that have been built before this, that is the video on limit and the video on continuity. It will help you to understand this concept more better. So let us recall the concept of differentiability at a point. A function f of z is said to be differentiable at a point z equal to z naught if the following limit exists. That means, suppose we have any domain and there is a point z naught. So we want to see what is the change if when we displace the point z naught to z naught plus h. What is the change in the function? So the change in the function is f of z naught plus h minus f of z naught, change with respect to the variable h, and when we take the limit as h approaches to 0 in the limiting case, this is told as f dash z naught. That means it is said the differentiation of fz with respect to h, right? So now, what is the concept of differentiability of a complex function? Now, suppose there is a domain D and we have a point z naught in this. This point has been displaced by z naught plus delta z. So the change in the 2 points is delta z. So how do we define the limit? We say that what is the change in the function? It is f of z naught plus delta z minus f of z naught. Change is how much? Delta z. And when we take this limiting case as limit delta z is approaching to 0, this limit is told as f dash z naught. So you can see that there is no change in the definition. Instead of h, we are just taking delta z, so it is representing a change in the complex function, right? So the concept of limit, you already know how to calculate the limit. So by the same technique, we are going to calculate this limit. And if the limit values are existing, they are same, then we will say that the function is differentiable. If they are not existing, that means we will say that the function is not differentiable, right? So let us find out the derivative of f of z equal to z square. So according to the definition, we will have limit delta z approaches to 0, f of z plus delta z minus f of z divided by the change, that is delta z. So f of z is z square, f of z plus delta z will be z plus delta z whole square divided by the change delta z, and take the limiting case as delta z approaches to 0. Now when we open up the brackets, we will get z square plus 2z delta z plus delta z whole square minus z square divided by delta z. So you can see that z square gets cancelled, and you can also divide by one of the delta z, and you will be getting 2z plus delta z. Now in the limiting case, as delta z is approaching to 0, so this value will become 2z. So we already know that z square derivative is 2z. So this is the method of calculating using the definition of limit, right? So now let us check this exercise. You are given that for the function f of z equal to real part of z, we need to mark the correct options, whether fz is continuous, not continuous, whether it is continuous but not differentiable, whether it is differentiable, whether it is continuous as well as differentiable. So let us see what is this function. So let us check the definitions of continuity and then differentiability. So for continuity, we have to see that limit f of z as z approaches to z naught should be equal to f of z naught, right? So if now what is z naught? Z naught is x naught plus iota y naught. So as z approaches to z naught, that means x will approach to x naught and y will approach to y naught. F of z is real part of z will be x. So on taking this limit, real part of x, x will become x naught, and hence it is same as the value of the function at the point x naught, right? So thus it is a continuous function. Now let us check for differentiability. Now for differentiability, the limit is f dash z is limit delta z approaches to 0, f of z plus delta z minus f of z divided by delta z. Now limit is delta x approaches to 0, delta y is approaching to 0. Z plus delta z will be x plus delta x minus x, and delta z would be delta x plus iota delta y. So x will get cancelled from here, right? So along the first path, when delta x approaches to 0 and delta y approaches to 0, let's take delta x approaches to 0. So we will get 0 upon iota delta y. That will turn out to be 0, right? And along the second path, path number 2, first let's take delta y approaches to 0 and then delta x approaches to 0. So when delta y approaches to 0, we will get delta x by delta x. So that will become 1. So you can see that along two paths, the value of the limit is not same and hence the function is not differentiable, right? So what is the correct option? The function is continuous, but it is not differentiable, right? So let's check another question. So we have to mark the correct options for the function f of z equal to z bar. So let us try this question. Now, what is f of z equal to z bar? Z bar means conjugate, so it is x minus iota y. So let us check first of all whether fz is continuous or not, right? So for continuity, we will take any arbitrary point, let limit z approaches to z naught f of z, right? So this should be equal to the value of the function at the point z naught. So what is f of z naught? Z naught would be x naught minus iota y naught, right? So limit z approaches to z naught means x is approaching to x naught and y is approaching to y naught. So f of z. So when we put these values in f of z, we will get x naught minus iota y naught. So can we see that limit x approaches to x naught, y approaches to y naught, f of z is equal to f of z naught, and hence this is continuous, isn't it? Okay. Now let us check for differentiability. Now for differentiability, what will happen? Let's check again f of z equal to z bar, whether it is differentiable or not. Now for differentiability, we have to apply this definition. F dash z naught is equal to limit z approaches to delta z. I'll just change it. This is f of z plus delta z minus f of z divided by delta z, and we have delta z approaches to 0, right? This is the definition of f dash z, right? So let us apply this definition. So we will have limit delta z approaches to 0 means delta x approaches to 0 and delta y approaches to 0. What is f of z plus delta z? F of z plus delta z would be z plus delta z whole conjugate. So this would be x plus iota y plus delta x plus iota delta y. So in other words, this is x plus y plus iota times, I can write it as x plus delta x, right? Plus iota times y plus delta y. So the conjugate, I have to write the conjugate of this function. So it will be x plus delta x minus y plus delta y, right? So f of z plus delta x would be x plus delta x minus y plus delta y. And what is f of z? F of z is x. I have an iota also here, isn't it? I missed out the iota. X minus iota y divided by what is delta z? It is delta x plus iota delta y. So let us simplify the terms and then write the expression. Delta x approaches to 0, delta y approaches to 0. So I can see that x will get cancelled, isn't it? And y will get cancelled. So what is left? Delta x minus iota delta y divided by delta x plus iota delta y. Now let us choose path 1. Path 1 is, first let us put y approaches to 0. So when we put y approaches to 0, I will get delta x by delta x, which is limit x approaches to 0, delta x, sorry, it is 1, so the limit value is 1. And what about the second path? Now let us put delta x approaches to 0 first. So I will get minus iota delta y divided by iota delta y. So that will be minus 1, right? So you can see that the function is not differentiable. So it is continuous. It is continuous but not differentiable, right? So you can accordingly mark your correct option, right? Okay, so it is continuous but it is not differentiable, right? So now you can check this question. You can try this question on your own, and I'll give you the correct option also. It is continuous and it is differentiable at the point only z equal to 0. So you can check this option, right? And now let us check another question. We are given the function f of z is imaginary part of z, and we need to check whether it is continuous, differentiable, or it is what, right? So when the function is equal to imaginary part of z means it is equal to y, right? So limit as x approaches to x naught, y approaches to y naught, the function will become y naught, and it is same as the value of the function at z naught, right? So the function is f of z is continuous. It's a polynomial function, so it is always going to be continuous, right? Now let us check for differentiability. Now for differentiability, the definition is f dash z is equal to limit delta z approaches to 0, f of z plus delta z minus f of z divided by delta z. So this is limit delta x approaches to 0, delta y approaches to 0. What is f of z plus delta z? It is imaginary part, so it will be y plus delta y minus f of z is y divided by delta z is delta x plus iota delta y. So y will get cancelled and we will get limit delta x approaches to 0, delta y approaches to 0, delta y divided by delta x plus iota delta y. Now let us check the limit value along the first path. When first y approaches to 0 and then x approaches to 0, right? So let us put y approaches to 0, so you will get 0 by delta x, so that will turn out to be 0. Now along the second path, path number 2, when limit, now let us put x approaches to 0. So when x is approaching to 0, you will get delta y upon iota delta y. So you will get the value as 1 by iota. So again, you can see that it is not differentiable, right? So it is continuous, but not differentiable. So I hope the question is clear, right? So the answer to this question becomes the function is continuous and it is nowhere differentiable, right? Okay. So we have a well-known result that differentiability always implies continuity, but continuity never implies differentiability, right? So you have seen several questions where the functions were continuous, but they were not differentiable, right? So thank you so much for listening to me, and those of you who liked the video, do hit the like button. And those of you who haven't subscribed my channel, do subscribe my channel to get the latest updated video. So believe in yourself and you will definitely succeed. Thank you.